I am going to, recording in progress. Okay, I am going to share a screen. And I am hoping,
There it is.
there it is, accepted. Okay, so is everybody seeing it? Yes, great. Okay, so we are going to be talking today about my colleagues and I about our open access basic biotech methods lab manual. So my colleagues and I have been working on this actually for many years, and we did some updates and revisions while we were sitting at home during the pandemic. But what's new is that it is now freely available. We worked very hard with the publishers to get this to be an open access manual so that you and your students can freely use it and use bits and pieces of it however you like. But at the same time, as we want to talk about what's in the manual, we also want to talk about how we can use teaching the basics like lab skills, like, I don't know, pipetting or using a balance to really build our students' scientific understanding. So even very simple exercises can help students to explore big ideas in science. So in particular, we're going to be talking about enhancing reproducibility and variability. So that's going to be a big theme in this webinar. So I am Lisa Seidman. I taught in the biotechnology lab technician program at Madison Area Technical College for 30 years and helped found that program. And Jeanette is here. She'll be talking a bit. Jeanette, you want to say something?
Yes, I came about 5 years after Lisa to the program after a brief stint at a small biotech company. So I was teaching with her for about 25 years.
And Cindy, you want to say something?
Yes, I'm Cynthia Moore. I've been a professor and the director of biology teacher education at Illinois State University, but I have worked with Lisa for many, many years through all 3 editions of our main textbook that we'll be talking about later in the seminar. So,
and I want to just note that Oana Martin is here, and she will be giving us some comments a bit later. Oana is currently teaching in biotechnology at Madison Area Technical College, and she's been using the Open Access Lab Manual, and she offered to talk a little bit about how she's doing that. And I also want to acknowledge that Mary Ellen Krause and Diana Litsky are co-authors on the manual that we'll be talking about today. So you're going to see the slide twice. This is how to get into the manual for those of you who maybe haven't seen it. Cindy set up a website for us. It's basicbiotechmethods.com. And there is a button that you can click on and you can go to the Open Access Lab Manual. So we're going to be showing the slide again later on, and Cindy will be talking a little bit more about this website and how you get into the lab manual. But we thought it'd be kind of fun to start out with an activity that comes from the lab manual, one of the easiest, simplest of the activities, and to talk a little bit about what we can learn from it. So what you're seeing here is a picture. There are 2 thermometers shown, one with blue dye, one with red dye. They are both in the same beaker, and they have both been in water, equilibrated to room temperature. So if you'd like to play along, what we would like you to do, if you're willing, is to get a paper and pen and record the value for what you read on the blue thermometer and what you read for the reading on the red thermometer. And while you take a minute to maybe find a pen and maybe take a look at those readings, I'm going to talk a little bit about how this would work with our students. So they would be seeing real beakers and real thermometers, and they would be making some readings of those real things. And then I would be asking them to put their readings, what they recorded, onto the board, blackboard, whiteboard, maybe an overhead projector. And that's what we're going to ask you guys to do in a second. We're going to have you put your values into the chat. And I'm going to cue you, I'm going to tell you how I would cue the students. So it basically cue you the same way. What we would cue the students, I would say, is be sure to record on the board exactly what you put on your piece of paper, exactly what your readings are, because it's very easy to be influenced by other people. So students will certainly know that maybe somebody else is really good in the lab and they see that they have a different answer and they'll want to put down what the other person said. But it's very important for the students to record what they got. And I also tell them at this point, very early in the semester, that whatever they put on the board, right, wrong, good, bad, doesn't matter. And in fact, it's really great if people make mistakes in class, because that's where we want to make our mistakes. And we can use mistakes as an opportunity to learn. So that's how I would cue the students. So now we'd like you to record your value for the blue thermometer into the chat and your value for the red thermometer. Now, we're not going to take time to look at them quite yet. We just want you to record your values. So I'm just going to hover here for a minute while you guys can record your values. And what's going to happen next is Jeanette, while I'm talking, Jeanette's going to be looking at your values. And a little bit later, she'll be kind of discussing and talking about what you put into the chat. But while she's doing that, I'm going to show you student data. So I'm going to move on. Jeanette, are things recorded so I can move on ahead here?
Yeah, it's going really fast, so I'll see how well I do, but yeah.
Okay, great.
I can get some numbers anyway.
Okay, so I'm going to show you, while Jeanette's looking at that, I'm going to show you student data. So here's something from a Blackboard from some students. There are 3 thermometers shown: thermometer A, thermometer B, thermometer C. And then as you read down a column, those are different students' values. So for example, a student got 24.1 for thermometer A, the same student 21.2 for thermometer B, and 22.3 for thermometer C. So here's the data up on the board. And then I would say to the students, do you see variability? And yeah, obviously they do. They all see variability. But then the question is, okay, why? Why do you see variability? So one of the things the students might come up with, maybe with a little prompting, is maybe the water is not homogeneous. Maybe the temperature is not constant. And then I will tell them, well, that is a really great thought, possible, but not the case here, nor with your thermometers, because for the students and for you, I let the temperature of the water equilibrate to room temperature. So it's pretty constant. So point out to them that variability in the sample or whatever we're measuring is always a possibility. So we have variability. It could come from the sample. It could come from the subject, in this case, the water. Okay, why is there variability? Then the students will always say, well, there's differences in how we read the level. So they'll say, oh, I saw somebody else, squatting down so that their eyes were exactly level with the meniscus. I didn't do that. Maybe I should have. And then they might say, well, I saw some students do something like touch the thermometer, and then maybe they even took it out and did not put it back in properly. These would be mistakes, and we can point that out. And we can point out at this point that these kind of thermometers need to be immersed to an immersion line. So maybe we can look at them and see maybe a student took them out and did not immerse them to the immersion line. So this is a great opportunity to talk about using thermometers. So people's technique is always a possibility when we see variation. It can just be variation like how did they read the meniscus, but it could also be mistakes. We can also talk about systematic errors, which might make the readings consistently too high or too low. So now we have the sample, the subject, and people. Okay, we also have differences between these thermometers. So variability can clearly arise because the thermometers are different. And then we can talk about how much variability is tolerated. And we can talk about specifications. Turns out that for this kind of thermometer, the manufacturers say that the tolerance is plus or minus 1 degree C, which is a pretty broad specification. And then we can say to the students, okay, is this much variability okay? And I'm not even going to try to answer that question for you right now. But we can then say, do we know the actual temperature of the water? And if we just looked at one thermometer or one reading, we might think we nailed it. Like if we just do one reading and we see 21.4, we say, oh, yeah, I know the temperature of the water. But actually, in this case, and in the case of measurements, when we have variability, there's also uncertainty. And so we can point out to the students there is uncertainty in our measurements. And this is a really important concept in measurements. So we have these 3 things that can cause variability. 3 broad categories: people, sample, subject, and instruments. So just with this really, really simple activity, we can introduce some really big concepts in metrology. So in fact, there's always variability in measurements. If we don't see it, the system is not sensitive enough to detect it. So this has to do with uncertainty, big principle. And really important for the students is we need to try to reduce that variability as much as is possible. So, Jeanette, I'm going to turn, do you want to talk a little bit about what we have here? And we're not going to have Jeanette share the screen because of the transition, but we'll just have Jeanette talk a little bit.
Well, they can see the chat if they want. I mean,
Great, yeah. Okay.
It's available for everybody.
Yeah.
But we have kind of a very simple situation here that's much less complicated than a real world situation because we're only looking at a picture. So the only thing really we have that's going to cause variability is your ability to read the picture and the thermometer itself, the instrument itself. So all those things, the homogeneity of the water, the fact that it's equilibrated, whether somebody picks up the thermometer in the wrong way, all that's off the table. However, and yet there is variability. Okay, so there is actually ranging on the blue guy, there's ranging from 21 by itself to 22.5. There is variability on the red side, and mostly in terms of how many figures. There's some people that just had 23, and a lot of people had like 23.0, 22.8, 22.5. So there's still variability. And
Okay.
yeah, and yet we still don't
Yeah.
really know the exact temperature
Right.
of the water.
Okay, that's really cool. You know, when Jeanette, Cindy, and I did this, we were exactly spot on with each other, but we were talking to each other. So we certainly
Yes.
probably influence one another.
Plus, we might have taken more time to do it.
That's
you
right,
know.
we might have. And so this would be an opportunity when I see data like that. And when, again, what we're going to suggest is that if people have comments that they want to make about this, we're going to wait till the end of, we were going to have time, we hope, at the end for discussion and for questions and answers, and maybe talking about thermometer readings. At this point, though, with students, I would certainly talk about significant figures, and probably they're getting hit with that a lot in their chemistry classes around the same time. So that would be a concept that we would want to talk about at this point, but we're gonna avoid that right now because we're just gonna keep moving on. And what I'm gonna do is to show you a little bit about what's in the table of contents for this manual. So you have a sense when I say basics, what am I talking about? So the first two, what they call chapters, I would call these units, are safety in the laboratory and documentation. Obviously really important. Everybody's going to talk about safety and try to work in a safest possible way. And documentation is hugely important in our industry. And everybody, I'm sure in your classes, you're hammering on this. So we have a unit to introduce it to the students. Now, where we actually started this webinar is in this unit 3, which is metrology in the laboratory. And I want to point out a couple more things here while we're on metrology. First of all, that you can see on the right that every unit is separately downloadable, and that's really convenient. It just makes it easier to pick and choose parts of the manual that you might want to use in your classes. And I also want to point out that every unit starts with some unifying concepts. So for example, there's unifying concepts in metrology. And so the manual is intended to stand alone. So if you didn't have some other textbook, it is intended that you'd have enough background in this manual to teach it from it. So for example, unifying concepts, accuracy and precision. We always want our students to know about that. Standards, calibration, measurement, traceability, important concepts in metrology, tolerance, systematic and random error. So these things, and I also even mentioned uncertainty, which is a much more complicated concept, but true in measurements, is that these concepts apply if we're talking about something simple like reading a thermometer or a graduated cylinder or a spectrophotometer, and they're going to apply when the students start to learn about more complicated measurement systems in their careers. So the next unit is spectrophotometry, and we talk a lot about how spectrophotometers work, and then we use them in a later unit to do assays. The next unit is biological solutions. I will come back to that one and show you some data from students and assays, and I will come back to that one also and show you a little bit of data from that unit. And then the final two units are biological separations and growing cells. So biological separations, pretty simple, well, pretty basic techniques. We talk about filtration, centrifugation, we touch on electrophoresis, and we touch on chromatography, but that's pretty light. I mean, this is a basic manual, so we don't get too deeply into those. Growing cells, we're biologists, we're going to grow cells. Again, we're hitting on the basic concepts. Aseptic technique, counting cells, growth curves, the difference between bacterial growth and mammalian cell growth. We have labs for both kinds. Making media, knowing about contamination, recognizing contamination, interpreting growth curves, and stuff like that. So again, basic concepts in growing cells, about growing cells. So now returning to the biological solutions unit, there's a number of activities in here. They start out with very simple ones, like dissolving any salt, a single salt into solution. It's very simple. And they get more complicated as the activities go on. But what's really important here, partly, is that we're adding complexity. We're going to be measuring one or more weights. We're going to be measuring volumes. We're going to add in pH as we get further down into the unit. They have to be combined properly. We do some calculations. And We have to have a way to detect variability. This is really important. If we don't perform some kind of quality control on the solutions, we don't know if there was variability and we don't know if there were errors. The way that we do it is with conductivity measurements, and there are conductivity values in the manual as guides. And you could use osmolarity. We've just found that conductivity instruments are cheap. They're easy for the students to use. They can give you a really quick reading, and they work really well for checking out the solutions that students make. So I'm going to show you a little bit of class data. So the first one is for magnesium chloride. So this is a single salt. All they have to do is dissolve it. And their values, you can see, are pretty variable from 139 to 3,380 microsiemens per centimeter. So I've cheated a little bit in showing you this particular set of class data. Usually it's not quite this bad, but this is really variable. So this is a great opportunity with the students, because then I can say to them, where is all this variability coming from and what should they do now? So they have something to really work on. And then in the particular case of this class, they went back, they talked to each other. I don't actually know what the problem was, but I know that they fixed it because they did it again very quickly and their results were great. So in a very short period of time, whatever the problem was, they fixed it. Now, if we move into something that's a lot harder, breaking buffer. So now we have something with a particular pH, we have a multi-component solution. And this is kind of interesting data. I just want to point to the bottom value. This is for Saeed. So his pH was 6.76, should be 7.6. And his conductivity is much higher than higher than the other students. So what clearly has happened is Saeed has added too much acid, and he's brought his pH down too low. And there's a couple interesting things about this. First of all, he didn't notice this until we put the data on the board. He wasn't really paying attention to it. And second of all, Saeed is a very sophisticated person. He actually is an international student who was in Madison. He came to Madison to take classes at the university and some classes from our college. And in his own country, he has his own research program. He has his own lab. He's a PhD person with graduate students and technicians. And he was mortified when this happened to him. And he quickly did fix it. But the point here is that even experts, even people like Saeed, who's working hard, who knows what he's doing, still can have problems and still can make mistakes. And we need a way to do quality control. We really don't want our breaking buffer, our reagents, to have mistakes in them. So moving on to the assay unit. Now, in the old days when I used to teach students about assays, it was really hard to come up with something commonplace that they would recognize. And the only thing I could come up with were pregnancy test kits to introduce assays. But it's way easier now because everybody knows about assays, because we all know about COVID tests. And actually people are a little bit more sophisticated because they know some of the problems with COVID tests. And, they've talked about, with their friends, can I trust it? It gave me a negative result, but I don't feel good, So people are much more familiar with assays. So assays are how we get data, obviously very important. Quality control labs use them all the time. Experimenters, researchers use them all the time to get data. So again, we have principles of assays that we can introduce. The whole idea of assay validation, or verifying that our assay works properly in our lab. Again, we have accuracy and precision, but we also have some other things. We have specificity. So does our COVID assay only react to the COVID virus, or might it react to flu? Well, that would be very bad. They are specific. Limit of detection, range, linearity. These are all concepts that are very important and we can get at with assays. So I'm going to show you just one set of data from the assay unit. Now, I know you can't probably see this very clearly, so I'm going to talk about it. What we have here on the left is a standard curve, and on the right, there's another standard curve. These are for an assay to determine the concentration of DNA in a sample. So this is a spectrophotometric DNA assay. And what you may not be able to see is that the graph on the left has the maximum value on the y-axis for absorbance of 0.3, 0.3. But the standard curve on the right goes up to 1.2. There is a really clear difference between these two. Well, what is that difference? And it turns out it's the effect of mixing. So we had a technician, a student technician who's very skilled, run all of the labs that are in the manual and get us some data. So when she intentionally messed up her mixing, we get a graph where the highest value on the y-axis is 0.3. Whereas when it's properly mixed, it goes up to 1.2. So there's a really clear difference in this assay. Mixing turns out to be critical. So this is the kind of thing we want students to understand. There's a lab where they take the Biorad protein assay kit. They just take the kit and they do various things to try to mess it up. So they might try to, what happens if I put in too much protein? What happens if I put in too little protein? What happens if I throw in detergent? So they do various tests to try to verify and understand how that assay works in their hands. So at this point, I want to throw in a comment about math. So I couldn't think of a good place to put it. So I put it here. So math, if I look at this manual and I just sort of leaf through it, which I did in preparation for this webinar, there's math on almost every page or most of the pages. It might be graphs like this. It might be making a calculation. It might be, oh, I don't know, growth curves and trying to figure out what they mean about the cells. It might, who knows? There's lots of math all over. It turns out that I'm on another grant project called Needed Math, and we are trying to figure out on that team, well, with past projects, what is the math needed in various workplaces? And the team is now writing a grant proposal to try to figure out what will be the future needs for math. What do students need to know about math in the future in the workplace? And everybody's saying, AI, oh, that's really going to change things. AI is going to come in and it's going to do all this math for people. And oh gosh, maybe they won't need to know any math at all. There's going to be robots, there's going to be automation, there's going to be AI. It's going to change the world. So that is one of the theories that's out there. And I'm sure you guys have heard this talk too. So I did do the little experiment of saying to AI, I asked ChatGPT to do the calculations to make a standard curve from one of the labs. And I'll just show you a screenshot. ChatGPT gave me a beautiful answer. This is a really small portion. It shows using the C1V1 formula. It goes right through it. It tells you everything, how many microliters you would pipette of each thing. It actually asked me, do I want student worksheets to go through this? Do I want student worksheets with blanks to go through this? Do I want more examples? Beautiful. I think there's no question that AI can do calculations for us. But what I don't think it can do, I don't think it's going to take the place of math literacy. I'm pretty convinced that even if the students were told how to make the dilutions, the calculations, they would still need to know, what does it mean that the y-axis on the left only goes up to 0.3 and on the right it goes up to 1.2? They still need to understand what they're looking at. They still need to understand a standard curve. They still need to understand, what does a growth curve mean in terms of cells, instead of in terms of cell health. So I don't think we're going to take away math literacy with AI. I think we could take away the calculations, but even there, I think we have to be careful because somebody still needs to be able to proofread. AI needs to be able to proof these calculations. It's very creative. ChatGPT is creative. It wrote me a gorgeous birthday card for a friend, but it also hallucinates. It's so creative, it makes things up. And it makes mistakes. So I told it in one case, I was writing instructional materials for the math project. I told it to make me a picture of an egg carton with 12 eggs, 1 dozen. It made me a picture of an egg carton with 10 eggs. So I told it, make me a picture of an egg carton with 12 eggs. It made me a picture of an egg carton with 48 eggs. I said, no, I want 12 eggs, 1 dozen. It made me a picture of a carton with 24 eggs. I said, ChatGPT, why can't you make me an egg carton with 12 eggs? ChatGPT said, I don't know. So bottom line, how much are we going to trust the AI? It's not perfect yet. Our students still need to understand. At least somebody in every lab is going to need to understand how to proofread the things that AI does. Math literacy, still important. So some summary points up to here. Good science requires reducing variability and increasing reproducibility. We need to be able to detect variability. If we don't look for it, we won't know it's there. We have to reduce mistakes. We have to control things like temperature effects, operating instruments, and so on. And errors made at the beginning will follow through. So errors made at the beginning, like in making our reagents, maybe in measuring small volumes, these errors, which are made in the very basics of the work that we do, can totally mess up our results from something really complicated and important that we did later on. And I'm going to use that as a segue to mention the reproducibility crisis. So in 2012, scientists at Amgen reported that they could only reproduce the results from 6 out of 43 groundbreaking research papers. That was really important because these were the papers that they were hoping to use as they developed new drugs, new treatments, new things. Scientists at Bayer can only reproduce 25% of results. This led to the term reproducibility crisis. Lots of attention. This is a cover from Science from 2018, Science Under Scrutiny. And if you think it's gone away, it hasn't. This is a headline from January 10, 2025. NIH sets out to double check biomedical studies because people are still concerned about this issue of reproducibility. So as people have talked about this crisis, what they've dubbed the crisis, they've talked about things like fraud and statistics. Now, fraud, obviously, we all hope that that's a very minor thing. To some degree, I think we are actually teaching our students a little principle there by telling them that they need to record on the blackboard their own data, whatever their data truly is, and not to change it because they think it might be wrong. Statistics is something I would not probably cover. The statistic problems they're seeing are past what I would be covering in a basic lab course. Antibody specificity, now that one's been coming up a lot as a possible cause of reproducibility errors. And specificity, although we're not doing immunochemical assays in this beginning lab manual, we can address the concept of specificity, so we can introduce that. Contaminated cell lines, another big issue. People think they're looking at kidney cell lines, they're really looking at HeLa cells. Again, we're talking about contamination in this manual. Reagents we are hammering on in this manual, very important in ensuring reproducibility. Volume measurements, as I mentioned, could be really important. And of course, documentation, which we all emphasize. And if you haven't documented what you're going to do, you're not going to be able to reproduce it because you don't know what it was. So I think that we're really working towards helping our students to make more, to be more reproducible in their work. So in those of you working maybe more in biomanufacturing, you may be using terminology like reducing variability. Those of you more in a research setting might be talking about enhancing reproducibility. Two sides of the same coin. Either way, what we're trying to do is to get our students to generate quality results, and we're hoping to use these basics as a vehicle to teach them about that. And so at this point, Oana, I think you're here. And Oana, can I ask you maybe to say a few words at this point?
Of course. Thank you, Lisa, for inviting me to speak. I really enjoyed this talk. It was such a good perspective of the book from your angle. I wanted to start by, I only have a few minutes, but my most vivid memory of using the lab manual, Lisa's manual, is as a new part-time instructor I won't do the math. More than 10 years ago, when I started in the program, I was assigned the laboratory skills course, and I received Lisa's lab manual with a companion book. I should emphasize that there is a companion book that we all love in the program, and that helped me dig deeper into the concepts I was lacking, because even after my PhD in the sciences, I was still a little unclear on some of the basics, I have to admit. So the companion book helped me with that. But my most favorite part about the book are the discussion prompts at the end of each experiment. And I know, Lisa, you talked about that, and you showed student data. That's what I still do. When I teach lab skills, students write data on the board. We have a very valuable discussion and point out possible sources of error. And I carried this to other classes as well. I got into this habit, and I have a collection of photos from all sorts of data from different classes that I appreciate, because then I can go back every year and try to connect them and see if the concepts changed, if the student understanding changed, the way they prepare solutions may be different. I noticed a change over the years in how students tend to work fast and get through tasks faster. So slowing them down and going back to the basis, I think, is very important. And Lisa's approach to laboratory teaching does that. This morning, I want to say I was digging into this book a few days ago because I pulled a centrifugation activity from the book. We were learning about centrifugation in bioprocess technology, and I thought, well, the students did a couple of runs, but we need a little bit more. So there is a very beautiful classroom activity with 3 scenarios that are laid out for different situations where students have to choose parts of a centrifugation experiment, and they have to order a microcentrifuge and adapters, and so the whole class loved it. They were in teams, and they completed it pretty well. So that's another aspect of the book that I like a lot. In addition to the lab, there are activities and scenarios, and I guess a little bit for every situation that an instructor can face. So simple activities, like Lisa pointed out at the beginning, simple activities are emphasizing very complex concepts, and they are a very good way to follow up a lab. So I don't know. I don't want to take
That's
much.
great. I know that's
I'm
absolutely
very
great.
excited about this
No.
book, and the fact
Yeah.
that it's free and it's now online is huge for the students too, because then we can use it in pieces in different courses, and they don't have to carry the big lab manual with them anymore. So they appreciate that.
Yeah. No, I appreciate you talking, because you are actually using the manual, and it's one thing when I use it. I mean, obviously, and it's different when a new person uses it, or a different person. So that's great. I appreciate it. Thanks, Mana.
Thank you.
And yeah, okay. So I'm going to come back to this slide that I said that, we were going to come back to this. So this is a website that Cindy put together for us, and I'm going to turn the mic over to Cindy, and you're on.
All right. Well, over the years, our team has developed all kinds of basic biotech methods resources. So we created the website to share those resources with other instructors who might find them useful. Our team has created a series of 3 standalone textbooks on this topic, all of which have been recently revised. To get more information about those books, obviously the little learn more buttons will do the trick. The lab manual, again, is free for download. What we call the big book, the Basic Laboratory Methods for Biotechnology, and it is a big book, is currently available, as well as the calculations book that we have, which is full of problem sets and scenarios for students to work with. The 2 books on the left are not free, but our lab manual now is, which we're very excited about. All right, let's go to the next, I think. We have a page with our free resources. I'll point out that arrow. That arrow is pointing to a teacher's guide that Lisa has made available to support the lab manual. The lab manual itself contains all the background, or most at least, of the background information you'll need, and all of the instructions for setting up the activities and running them. The teacher's guide is simply a set of notes that Lisa has put together to go along with it. So the teacher's guide is optional, but might be worth a download. Among the resources, we've got slide presentations, various scenarios for students to work through, problem sets with answer keys. And I will particularly draw your attention to the bottom of the screen where it says the measurement of pH selected ions and conductivity. This is actually a full chapter from our big book. So you can kind of get a feel for that. If you would like more information about pH, it goes into a fair amount of depth on that. We also have a breakout page for the safety resources since we had a number of those. So you can find those on a separate page. And we are continuously uploading new resources. All of these are free to download, and most of them you can modify as you like. And then finally, we also have a blog on the site. This is where we're putting various thoughts about basic biotech methods, as well as discussing any updates to our website or any news that we have to share. So please feel free to read those and add your comments to them. We also have a subscription box. It's just off screen at the bottom. If you provide your email, you will receive notification when the blogs have been updated. I promise you're not going to get spam with this. We don't post the blog every day, certainly. But we will post in the blog to tell you when there are new educational resources posted. So you don't have to keep checking back to see what changes we're making. All right, that's basically
Okay.
So
Okay,
Lisa,
thanks. Oh, yeah,
back
right.
to you.
Okay, so I did want to put, yeah, so thanks. We did want to leave some time, which I think we have left time, so that there could be questions or discussion. I also want to point out that my email is here, and you can reach me or any of the other speakers through that email through me. And I forgot to mention when I was talking about math that the needed math team is writing another proposal to submit in October. And we are looking for people who might be interested in writing instructional materials on whatever this math turns out to be in the future, which we are all wondering about what it's going to be. And so if anybody's really excited about the math, you could get in touch with me and let me know that you're interested. So I'm going to leave this on for just another couple seconds, and then I'm going to stop the share. And I think Cassandra and Jeanette and Cindy have been watching the chat, which I have not been watching. And we might have you know, people might want to share something. So I think people have had time to get my email, and I'm going to do stop share. And there you are. Okay. Thanks everybody for coming. And so do we have anybody who wants to have questions or say something?
Question.
Hey, hi,
Hey, look
Linnea.
who's here. Yeah.
Yeah. Yeah.
So I have a quick question and suggestion. So Innovate Bio now is at sponsoring information for people who are starting new programs or running programs. And we would like to connect to your site and then let us brainstorm how we can do a good job of this, because right now there are, like in Texas, the number of programs has just doubled.
Wow.
There are a lot of people starting programs. And then two, everything you said, I'm going to take your video, and there might be another possibility for a video, cut and pasting it, because it's good professional development for faculty.
Great.
One of the hardest things is trying to get faculty and students to understand, to reflect on what they're doing and what are the possible errors that are going to happen. So I just want to say, and I really miss you guys. Okay.
Oh,
So
we miss you too.
I miss you too. Yeah.
because I know. Go ahead.
Well, okay, yeah. I wanted to point out that we would definitely love to connect the two websites. We've tried really hard to keep ours to be very focused on basics. You know, and obviously, you know, Vape Bio's website is wonderful, and it's got, you know, career resource. It's got tons of good stuff. So yeah, connecting the two sites would be great. And
Okay.
we can talk about that maybe, you know, later off the
Maybe
Zoom call.
over a margarita. Okay, so for everyone to understand,
Yeah.
that comment was that I've known these two and Jeanette for a long time, and we had many discussions over
Yeah.
Yeah.
margaritas and wine.
Or wine.
Thank you.
Yeah.
Or wine. Yeah.
Yes.
All right, Maggie, I don't want to take up the time. So good to see you.
Oh, that's okay. I just want to say congratulations on the website. The layout is great. It's so clear. And, you know,
Right.
as Linnea was just saying, this is great for a new faculty member coming in or adjunct faculty just to direct them to this. And,
Good.
and that was me about 15 years ago when I found on the BioLink website, Lisa's course in a box for my
Mhm.
instrumentation
wow.
class. And that's where I started. So I faithfully use your conductivity tests for my solution prep, and I have all these years and set specifications that they have to, you know, have their solutions be within as far as conductivity, and if they don't, they have to make it again. But it gives them that whole idea of quality really early on, just like you were saying. So this is wonderful, and congratulations, and I'll be passing it on to as many people as I can as they sort of start their journey.
Thank you.
So thanks, guys.
That's really great. Thanks.
Thank you.
And I'm sure that Sandy's very pleased to hear that it's nicely laid out. She worked really hard
Yes.
to lay out that website
Oh,
and make
that's
it
all,
clear.
Cindy.
Well,
Yeah.
my main goal was to make sure people didn't call it up, roll their eyes and laugh. So
Right.
we tried
Right.
to make it pretty clear in terms of navigation and everything.
Right,
So
right.
thank you for the compliment.
Yeah.
So I wanted to Innovate Bio would appreciate how many different ways you think that we should utilize this for the community. Because remember, the center is only for all of you. And if you tell us what you want, I can think of many ways of getting Lisa and Cynthia and all of their group and Jeanette doing things where the center would pay them, or we could organize workshops. And if you tell us what you want, we'll do it. We could use up all their time.
That'd be great.
Yeah,
I think we're really open to that.
I'm happy to do some work.
Yeah, we
I'm
are.
actually kind of bored.
You know, some of us have completely failed retirement. So,
Yeah.
you know,
That's
here we
why I
are.
didn't even bother to retire, because I already knew I'd
Yeah.
fail it.
Yeah. So I mean, there's a lot of people on this, you know, webinar some of whom I know and some of whom I don't. But, you know, if people do have ideas for things they would like, if they could shoot those to me or to Linnea,
Yeah.
you know, just get ideas out there of things that they would like.
Valerie has her hand raised.
Sure.
Did you guys hear me okay?
Yes.
Yep.
Okay, sorry, I was just driving, so I pulled over. I have a question. How do you use the electronic version in the class with the students? Do the students pull it up on like their phones or a device? Is there like a printed copy that like the classes use? Just curious how you guys go about doing that.
Oana, you're on.
I guess I can take that. I am a little bit old school, and I print protocols for my students because I don't like them all over their phones. I do post on, we have our learning system, learning management system, Blackboard, and I post individual labs from the book. But then I print the actual procedure that they follow. Some colleagues use computer laptops or iPads in the lab. We have both. And then the students can access parts of the book there.
Okay, yeah, thank you. Yeah, because I've been struggling with that because my lab's kind of small, but I also like they're not really supposed to have like electronics, like big laptops and stuff on the benches because you know you could spill reagents on them.
Yeah.
But I really want to switch, you know, to be able to do electronic stuff. So that's why I was wondering if anybody. I mean, I do the same thing right now. I do printed copies, but you know, it'd be nice to do electronic. But yeah, I was just trying to see if maybe there's some other, you know, ideas of what people are doing out there. So
Yeah.
thank you.
So Lisa, there's a question in the chat about the companion book that Oana mentioned.
Yeah.
They're wanting to know if that's one of the books that are posted on the website. And yes, it is posted. The big book is posted, the picture of it there. It's not, and this person already acknowledged that it's not free, but you can get an examination copy from the publisher.
Yeah,
So
and if you have trouble, let us know, because you're supposed to be able to,
supposed
I
to be-
think what they're making available is an e-version of it. The last time we checked, you couldn't get the paper version. You could only get an e-version, but that should be okay.
should be in
And yeah, and that one's pricey. And so, you know, take a look at that and see if it's going to be appropriate. You know, the way we use it with our students is we tell them it's going to be a resource for them into their careers. It's not a textbook like that you throw away after the first semester or after you use it. So we think it has value for that purpose.
So, and Maggie, you can download the manual directly from that website, our website. You can click on it. She was asking a question about reading from.
Yeah, I just tried to
Creative
do that and I wasn't able to. Then I saw
Oh.
this open access Creative Commons and I wondered if that's where we go to do it.
Well, that's for the lab manual, yes, but not the big, yeah, right.
Yeah, the
Right,
lab
big
manual is
book.
Creative Commons or
Yes, the
website?
lab manual is available in various places, including Creative Commons.
Okay.
Yes, yes.
When I click on it on the website, I have to click a couple of times, but it comes up. So I'll double check that and get back to you if there's a problem with it.
Thank you.
Yeah, it
Yeah.
should come up pretty easily.
Yeah.
And again, the big book, there's no way the publisher is going to make that one open access. So it just costs too much. It's just not going
The
to happen.
Bible of biotechnology. I call
Just-
it the Bible.
I know, it's just not going to happen. So as I say, it's, you know, you can get it with desk copies for, you know, teachers, and see if you think it might be useful for your students into their careers in the future, which, you know, we certainly designed it with that in mind. Were
I
there
saw
other-
Jennifer Lazar had a question for you in the chat.
Okay. Jennifer,
Jennifer,
you want to tell us what it is, what your question is?
Jennifer.
Hey, yeah. So I'm just thinking along, like, you know, like when we're doing startup for high schools, is
Mhm.
there like a comprehensive consumable list for all of the
Yep.
labs that you
Yes.
do?
Yep,
Okay.
yep. All that
Awesome.
stuff is, that kind of thing is in the back of the book,
Okay.
the lab manual. And then I'm going to acknowledge that Diana Litsky was our, she's retired now, but she was the lab manager for the program.
Mhm.
So she did an awesome job. You know, she knew
Awesome.
exactly, you know, all the safety issues with all the reagents.
Mhm.
So anyway, yeah, so all of that's available, and we tried to update it, as I say, during COVID.
Mhm.
Now, it could be that there's going to be some changes, you know, that, because that's kind of a moving target.
Right, right.
But it was updated, you know, at least, you know, a few years ago. So.
Thanks. I appreciate the cost value. Like if you're a startup, like a startup high school teacher,
Mhm.
I mean, the cost is minimal, right? Compared to if you
Yeah.
have to buy like 10 kits to run a class. So
Mhm.
anyway, I appreciate that too. Not only is the book free, but it's more affordable for startups.
Yeah, right.
Mhm.
And there's a lot of activities which are really cheap. We use sodium chloride a lot.
Yes, I noticed that. And dyes, yes.
and red food coloring. Yep. Yep. Right.
I think it'd be really worthwhile if I assume at your website that people can ask questions about how to use it. And then it can also be a blog, because we do that a little bit at the Facebook page for the center, but focusing on how to use the book in your program, in your classes,
Okay, yeah.
encouraging people to share that information. And if people wanted another session with these two wonderful people, these wonderful ladies, on how to use the textbook in their classroom and also for the entire program, I think of spreading it out across a program, because otherwise it's so information dense. You feel like you need to spread it out across the program.
Yeah. And that actually relates to a question we get asked with the big book, or with this, we get asked, so what course do you teach this in? And it's like, well, we
all of
actually, we actually do have a course called Basic Lab Skills. So we do get to a fair amount of this in one course in our program. But, and I think Oana alluded to this, you know, there's some things that you might do in she does in her bioprocessing course. There's some other, and proteins. Oh, there's tons of stuff in there that we do in a proteins course, which is basically upstream, or that'd be our downstream processing course. So we sort of have an upstream and a downstream. So in both of those two courses, there are some labs that are appropriate in the manual that would work. chromatography. We have a course in chromatography. So we have a couple of introductory chromatography labs in this manual. Nothing advanced. These are pretty simple ones to get across the principles.
Well, I would call actually the pH chapter very advanced, and that's one of the ones that's actually freely downloadable. I call it really advanced because I didn't know that stuff when I started teaching the program.
I know,
So
I know.
anyway, we were able to negotiate that one chapter to be free, so that you can get downloadable from the website. So.
Yeah, right. Yeah, I think when people think about open access, and of course we all want it, but we don't realize that publishers own all of these materials, and publishers want to make money on them. So it's not so simple to get open access materials. So anyway.
Well, if people want more webinars or even face-to-face workshops, you guys have to speak up and let us know, and we could see what we can do. If there's ever supplements again.
Yeah,
right. Okay. Yeah, and again, we would love to do more of these kind of workshops.
Yeah.
And sure. And you know, webinars by Zoom or in person, you just let us know.
In person is fun, you know.
Yeah.
I think in person would be, I just came from Jim Hewlett's in person undergraduate research, and I don't know about all of you guys, but I miss in person. So the center wants to do more in person if people are interested.